Hi, good morning to you. It's Jim from Mavstar Observatory. Coming up in this video, we've got some really important breaking news, which we're going to share with you guys. I think it's only fair to end the note of this year in the right direction and on a real exciting finish for the year, so to speak. So before we do, I want to thank those few people that have been supporting us, and if I can, try and encourage just a few more people before the end of the month finishes. We've got about 4 days to really try and end this on a bit more of a positive note for the funding that we've raised for the observatory. And in this video, I want to try and show you, exactly why it is worthwhile supporting what we do here. We're going to be talking about something that no other channel on YouTube and no other organisation has yet mentioned to the public in any way. So this is really hot news and breaking news, and I think with the evidence that I'm going to provide, you guys should be under no influence that what we are stating here in this video is the fact and not just speculation. And this is really through years and years of studying what has been taking place with our migration that we're in right now with the magnetic poles of our Earth. It's a rare event, and this is the first time humanity has experienced it, and we're here to document it. We have done an amazing job documenting this at a very high resolution to date, and I think the dedication and work that we've put in is the result of what we're about to show you. And by all means, this is not going to be the end and the top point of what we talk about here. It's going to continue into the next year, so long as we can keep being funded. So what we're going to reveal to you is, I think, very big news. And you got to remember, in the study of geomagnetics and this new anomaly, it is all down to what you collect. And I think with what we've done so far, we've done really well. So I'm not going to rabbit on any longer than what we need to. I'm just going to get to the facts. On the top left hand side, we've got today's temperature chart of the Earth, and on the right hand side next to that, we have the magnetic model that was published by NOAA this year. On the bottom left, we have the swarm data showing the magnetic intensities of the highest regions and lowest regions of the Earth. Over the top, we have the one covering Canada, over the right, the one covering Russia, and the one down just creeping up on the peninsula of Australia, we have over the southern hemisphere the highest magnetic field. And of course, that dark blue region is the mid-Atlantic anomaly, which we have discovered this year is appearing to break into two pieces, one over the continent of Brazil, the other over the south continent of Africa. So I want to concentrate first of all with our facts, what's been taking place over the northern hemisphere. And I know that the sync rate of the video is going to be out, so where you see the pointer talking is just really covering the three main regions over the North Pole, over the northern hemisphere, sorry. And I want to concentrate on this central patch here, what we can see in between Canada and Russia over the northern hemisphere. This is the part where there is no intensity really. When we look at swarms data on the bottom left, there is no strong intensity in this region, and it is one of the regions that always stays the warmest recently on our planet, whereas Canada is cold, and over Russia, which is the epicenter of where the magnetic North Pole is being drawn to, is the coldest regions over the northern hemisphere. It is no mistake, and we can prove that when we look at the released magnetic model for this year. We can see that right in the epicenter on the right hand top chart is exactly where the coldest region is on our planet. And we can see that in the center on the magnetic model chart that was released this year, the least intensity out of the two, and this is just confirmed with the satellite data from Swarm. This is telling us that where the highest magnetic intensity is where the coldest regions on our planet are going to be. And it is really important that we know this, because as the magnetic North Pole migrates and the South Pole migrates, it is going to be taking that Arctic an Antarctic climate along with it at some point. I believe the reason why we're not seeing it so clearly over the southern hemisphere is because when we look in the central map on Swarm's missions map, we see that the South Atlantic anomaly exists. I think if that wasn't there, what we would see is Australia right now getting colder climates. So it is probably a good reason for Australia that we have the magnetic low intensity in the Brazil region or the Atlantic region. And you know, I think the reason why we're seeing this clear picture over the northern hemisphere is because the pattern fits so perfectly, and there isn't a South Atlantic anomaly over the northern hemisphere of the Earth. Why is this important? Well, we're probably about 2.5 years, 2.6 years away from seeing the magnetic field cross the 40-degree mark, where it leaves the strong field lines into the weak field lines, and therefore we get the migration take place a lot quicker. What this is an indication of is that if it doesn't stay in the Russian region, and this is a question that I get asked a lot, where will the poles be after the reversal? I don't know, and nobody can answer that question. But for right now, I can say that the North Magnetic Pole is heading towards that region of highest intensity in Russia. And the reason why it left Canada in the first place 100 years ago is because it has gradually got stronger and stronger over the last 100 years. And it has therefore drew the magnetic dipole over towards it, and it will continue to do that as time goes on. We expect that in a couple of years' time, maybe 2 to 3 years max, it will start to speed up exponentially, as we have seen it change gear and cover more distance in a short period of time over the northern hemisphere. So we are gearing up to see some really unique things take place with our Earth. And what does that mean for Canada? Well, it could mean that Canada is about to start to see more temperate and warmer climates as Russia creeps into a deeper, colder period. And as you can see, this region is travelling, you know, if you look at just the regions outside the highest intensity on the swarm data map, what you'll see is that even on the outer edges of that high intensity, you know, and when we compare it with the temperature map, we can see that even in China now, and further down south into China, and those South China Islands getting colder and colder. You know, again, it rebuts the theory that this is starting to look not just theory but more like fact when we you know, consider what we're seeing here. And I think the thing that really gives it away is in between the two magnetic intensities. If we just look north over the northern hemisphere of the UK, we can see that there's less intensity there. That is by no mistakes there for that reason. I'll tell you why it's there, is because there is less magnetic intensity in that region between the two highest intensities over the northern hemisphere in Canada and Russia. So we know now that where the magnetic dipole moves to, it also takes the Arctic climate with it. And that is why for thousands of years the magnetic poles have been over the Arctic and Antarctic circles. And now we can confirm that with the data that we're looking at. Again, no other organisation has came out and made this announcement to anyone, so you are first to hear about this, and that is largely thanks to the people that have been able to support this research and our observatory in the study of the geomagnetics of our planet Earth during this magnetic reversal. Guys, that's the big breaking news, and as you know, we are coming towards the end of the year. We've got 4 days left. It would be amazing if we could see a few more people on the back of what we've made today, this video, people coming forward to support what we do. I know it's difficult times for everybody, but you know, we really need to keep this research going. I think the Mavstar Observatory needs to survive into the next years as this rare anomaly really starts to take grip on our daily lives, and it will do. You know, climate change is down to now, as you can see, the magnetic pole migration of this Earth. It should come as no surprise that in the last 30 years, not only have we seen a double in the movement of the North Pole, but we've seen also in those last 30 years the climate take some dramatic changes. It should come as no surprise that these two anomalies are now, I believe, firmly linked with each other, and this is part of the mechanics of our Earth with relationship to geomechanics and climate. It shouldn't come as a surprise to some people, but we're stating the facts. We just hope that on the back of this announcement, and I hope that you appreciate, this is big news. On the back of this, we turn somewhat round this situation with the low funding for the observatory in the last month of this year. So guys, I will mention the link down there, and I hope you join us in the new year. We are hoping to hit the ground running. We desperately need to get magnetometers into Brazil and Russia, and that's where we'll be focusing our attention in the new year. Guys, I will probably speak to you again before the month's out. I'm just hoping that you realise the importance of what we've discussed today in this video. You realise that we don't just talk on this YouTube channel, that we have a dedicated website that covers not just magnetic pole but a lot of other anomalies, and we give we put a lot of work into now every week, giving you an Earth health at a glance, which is like a temperature gauge in your car. You get to see just how the world is faring up with all these anomalies and changes that we're taking place through at this time. So enjoy the rest of your days. Take in what we've discussed here, and it gives you an idea of where things are going in the future with the changes that we can expect on our planet. The links are down there, and I'll say what we usually do here. As always, guys, bye for now.